Okay, this video will be on graphing inequalities. We're going to be graphing only one line per coordinate system. The next video will be graphing systems of inequalities. So then we'll have double lines, double inequalities on one coordinate system, okay? All right, this is similar to graphing lines, slope-intercept form, y equal mx plus b, except the equal sign is an inequality symbol, S-Y-M-B-O-L, okay? All right, so this is review. What are your inequalities? You have less than, greater than, less than, or equal to, that's like a half equal sign, greater than or equal to. Okay, so when you're graphing these, this is what we're using. This is when you were on a number line, this open dot, closed dot. Okay, so we're not using this. I just put that there just to get you to recall. Okay, this is where we are. So we're going to be graphing on a XY axis. So when we graph the lines, because that's what we're graphing our lines, less than and greater than don't have that equal to, so it's dashed. It's not inclusive. Okay. And then when it has less than or equal to, greater than or equal to, it's a solid line because it is inclusive. So I should probably write that. Inclusive, meaning includes. Okay. Not inclusive. Okay. So inclusive is solid, not inclusive is dashed. And we're going to verify when we shade, we're going to graph, we're going to grab a random point in the shaded and the unshaded region, and we're going to verify that inclusive, non-inclusive, okay? Okay, let me move down. Okay, so rise over run and your y-intercept shortcut of graphing is, those graph skills apply here. So we're going to use them. We're not going to use an XY table. Okay. We're gonna, if for some reason we're giving standard form of the line or of the inequality, ax plus by is equal to c, the constant, we're gonna rearrange from standard form, SF, we're gonna rearrange standard form into slope-intercept form, which is y equal mx plus b. Of course, the equal is gonna be an inequality. It's just you're so accustomed to seeing this, that's why I just kept the equal. Okay, and the reason why we're going to take standard form into slope-intercept form is so that you can make sure that you see that the accuracy of the inequality, okay, whether it is greater than, less than, so forth. Okay, we're going to graph the given line, solid or dash, meaning, right, we're going to verify that. And then we're going to shade above or below the line based on the inequality. Okay, so what does that mean? Oh, let me hold it so you can kind of copy. Okay, your y-axis is a vertical, right? Oops, axis. Okay, your x-axis is a horizontal axis. Okay, so the y-axis has a 0, right? So I only took half of it, of a coordinate system, right? I kind of split them apart. Okay, so your y-axis has a 0, which is your origin. And then you go up positive numbers, and then you go down to negative numbers. So positive numbers would be greater than negative numbers, and negative numbers would be less than positive numbers, right? Okay, so then if we look at the x-axis, okay, here's our 0, our origin. If we move to the right, we're in the positive numbers, and those are typically, right, they're greater than negative numbers. And if we move to the left of the 0, or the origin, we're in negative numbers, right? So those are less than positive numbers. Okay, why am I talking about this? When we go to shading, I'm going to ask you, I'm going to randomly pick two numbers, and I'm going to ask you which one's greater. And it's that easy, okay? You just compare, and you know how to compare numbers, integers. Okay, let us graph now. Okay, so that was that page. Oh, duh, sorry, page 2. Okay, so we're going to go ahead and graph these. Okay, so let us check. We're going to verify our shading. How? We're going to pick a point in the shaded region and the unshaded region. And we're going to verify this inequality that's given to us. So our inequality is y is less than or equal to negative 4x plus b. Plus b. Oh my goodness. Plus 3, but it's the b. Okay. remember our slope, if it's an integer, it's always over 1, right? So we're gonna graph shortcut here. Okay, so my y-intercept is 3. So 1, 2, 3. So here's my y-intercept. And by the way, if some of you are making mistakes by putting the y-intercept on the x-axis, because the graphs that I got off your quizzes, some of you graphed the first line right, and then the second line, you know, your brain sabotages you. Some of you then put, I think, the -2 on the x-axis, but you did the first line correct. It happens, so just graph it, slow down, look back, verify. Okay, this is a y-intercept, y-axis. The 3 is on the y. Okay, now my slope is -4, so I'm going to go down 4, right 1. So from here, so 1, 2, 3, 4, and over 1, here you go. Now, for those of you sending me graphs with just plots, that's a plot. That's not a line, okay? I want lines. Oh, yeah, I forgot. I have a ruler. I have ruler issues. Okay, so I'm going to kind of move this camera so I can... Oh, actually, no. Oh, hello. Move the ruler the other way around. I got it. Okay. Okay, I kind of jumped ahead. I didn't go over this with you. Okay, it's less than or equal to. Okay, so I have less than or equal to. And that's inclusive, which means it's a solid line. And so there's my solid line. Sorry, I jumped ahead. I didn't go over that with you. I just went ahead. Okay, so it is a solid line. Okay, so now we have to shade. We're on less, okay? So I want less. Okay, so look at our y axis. Okay, so, you know, just arbitrarily pick a number up here. Say it's 25, right? So we're guessing here. Okay, so say this is 25. And say down here, say it's -25. Okay, which one's greater, which one's smaller? So I have positive 25 and I have negative 25. I want less. The -25 is less than this positive 25, right? Okay, so this number is the less than number. So that means you're going to shade to the left or below the line. And so this is my shade. Okay, did I do this correctly? How do you know? All right, you're going to go ahead and pick 2 random points. So I'm going to pick a point in this random area, right? Oh, so by the way, we're done. You graphed this line or this inequality. Okay, so this is your answer. Okay, now in the directions of the assignment, you're going to be asked to also verify a point in each, shaded and unshaded. Okay, so I'm going to pick, oh, here, you know what? Let me mark it with a green or blue pen, just so you can follow along. Okay, so I'm going to pick this number, which is -30, and then I'll pick this number, which is 1, 2, 3, 4, 4, 1. Okay, so it's random. I just picked it, right? Okay, so now what I'm going to do, I'm going to plug the points into my inequality. Okay, so I'm going to take -30, oops, and I'm going to take 4, 1. Remember, x, y, right? I am so sorry I keep moving the camera. Where I'm sitting, I feel like I'm getting attacked by mosquitoes or something, which is weird because it's in the house, but I had everything open, all the doors and windows open, and anyways, okay, moving on. Okay, I'm going to substitute. So y is 0, -4, -3 plus 3. I get 0. This is 12 plus 3. 0 less than or equal to 15. Okay, is 0 less than 15? Yes, that is a true statement, right? Okay, so I shaded correctly. I substituted -30, and this region does in fact hold true to this inequality, less than or equal to. Okay, this one should fail because 4, 1 is not in the shaded region. It should fail, so this less than or equal to should not be true. So if I substitute negative 16, right? Because I multiplied. Okay, plus 3. Negative 13. Okay, is 1 less than or equal to negative 13? No, that is false. It fails. And so that is why that point is not in that region, shaded region. Okay, so that's your check. Okay, so let's move on to another one. Oh, pen. Okay, so here we go. My y-intercept is positive 1. So here's my positive 1. My rise over run is 2/3. It's positive, so I'm going to go up and to the right. Up, 2, right, 3. So 1, 2, 1, 2, 3. All right, so now I'm going to get my ruler. And, oh, okay, so here we go. Here's my inequality. It is less than. There is no equal sign, which means it is a dashed line, right? Okay, so how do I graph this? Let me twist it because I can, oh wait. Sorry. Okay, so here's my dashed line. I'll rotate the paper. Okay, so here's my dashed line because it's not inclusive, right? That equal sign gets the solid through and through line, right? Because that equal to. But if it doesn't have the equal to, if it's just less than or just greater than, it's a dashed line. Okay, so now I have to figure out how to shade it. Okay, so here's my line. Do I shade above it or do I shade below it? Okay, so if I have less, oh my goodness, I know, right? You guys are screaming at me. It's greater than. I was looking up. Okay, greater than. Don't worry, I'll end the video, I'll tell you it's greater than. Okay, so I want greater. Again, so say this is positive 25 and say this is negative 25. Okay, so looking at positive, I'm just picking, if for those of you wondering why I'm picking 25, I'm just arbitrarily picking a number that is so far apart from each other that it makes sense, okay? So is positive 25 greater than negative 25? Yes, positive is greater than negative. And so if I want greater, I'm going to shade above this dashed line so that I activate the absolute more positive, right, part of the y axis, right? Whereas if I shade it down, I'm going to get more and more and more and more negative on that y. Okay, so now how do you prove it? Again, you pick 2 points, right? So I'll pick... This is 1, 2, 3, 4. I'll pick 0, 4. And then I'll pick, say, 1, negative 1. Now, I'm just picking points here. You could have picked different ones. Okay, so here's my line. Oh, you know what? I should have picked, let's do this. Well, that one's okay. That one's okay too. Although, here, then let me, just because it's a 3, let's pick a multiple of 3. Okay, so we'll pick 3, 0. How's that? Oh, good, I didn't do it there. Okay, so let's pick our 2, 0, 4, and let's check them. 3, 0. Okay, so 0, 4 is in my shaded region, so that means that should hold true. My inequality should hold true. The left should be greater than my y side, than my right side, okay? 3, 0 is in my unshaded region, so that means that greater than symbol should be false. Okay, so here we go. If I substitute 4, 2/3, 0 plus 1, right? Because xy. All right, 4 greater. Anything times 0 is 0. So that's 0 plus 1. So is 4 greater than 1? False. Oh my God, true. I'm looking ahead. Okay, is 4 greater than 1? Yes, it's true. Yes, yes, yes. Okay, so then that means that that's why my 0, 4 is in the shaded region. I write with the phone over my vision, so I kind of go off memory. And apparently this one, I'm just doing so bad because I'm looking at the 3-0 thinking whatever. Okay, so here we go. Let's throw the 3-0 in. Okay, so 0 greater, 2/3, 3 plus 1. All right, so go ahead and clean it up. 3 into 3, right? Reduces to 1. So 0 is greater than 1 plus 1. Is 0 greater than 2? No, 0 is not a bigger number than 2. So no, this fails, and that's why 3-0 is in the unshaded region. So the way you verify whether or not you shaded correctly is pick a random any point in here, pick a point in the shaded, pick a point on the unshaded, and see if your inequality fails or is it a true inequality, like 4 is greater than 1, which is true. It's a true math statement. Okay, so that one's done. All right, so let's go to example 3. So example 3 is in standard form. This is in standard form. I tell you guys, put it in slope-intercept form. So how do I do that? I take my x term, jump that equal sign, and then you switch the sign, right? So I'm going to get y. Oh, it's equal. What do you guys want to make it? What did I do? Greater than, let's do greater than or equal to. Okay, greater than or equal to. So y is greater than or equal to negative 3x plus 5, right? So positive, jump the inequality, negative. But the positive is still in the right, so you leave it unchanged. Okay, so positive 5, 1, 2, 3, 4, 5, right? Every integer has a denominator of 1. So I'm going to go down 3, right 1. 1, 2, 3, right 1. Here's my point. 1, 2, 3, down 1. I'm just going to get another point. Okay, it's greater than or equal to. Greater, right, than or equal to. So that means this is going to be a solid line because it has that equal, right? Okay, so if I go to graph, it's solid. That's why I did 3 points, just because I have to do it one-handed. I just want to get a little bit more accurate. Okay, so solid line. Okay, so now we get to the shading. I want greater. So again, if I was to kind of extend this out, this is like positive 25. This is negative 25. I want greater. So is positive 25 greater than negative 25, or is negative 25 greater than positive 25? This one wins, right? Greater, I want more positive on the y-axis. Remember, as you move up, it's going to get more and more positive. If I was to shade below the line, I would get negative, more and more negative. Okay, so I want this part. And there you go. Okay, so now we're going to go ahead and verify. So pick 2 points. And actually, they're both, we don't have fractions, so it doesn't matter what we pick. Okay, so I'll pick 1, 2, 3, 1, 2. I'll pick 3, 2. And I'll pick 0, 0, right? That's an unshaded region. This is a shaded region. So this one should hold true. This one should hold false. All right, so what do I get? Y greater than or equal to minus 3x plus 5. Okay, let's do the true one on this side, and let's do the fail on this side. Okay, remember, xy, right? xy, xy. Okay, so substitute. 2, negative 3, 3 plus 5. I guess my numbers are kind of bigger. 2 is greater than or equal to negative 9 plus 5. 2 is greater than or equal to negative 4, and that is a true statement. 2 is greater than or equal to negative 4. Okay, so I shaded correctly. Okay, this one should be a fail, so let's substitute. 0, negative 3, 0 plus 5. I'm running out of paper to hold. Anything times 0 is 0. I need a second hand. 0 is greater than or equal to 5. Is 0 greater than 5? No. So this, hold on, let me write fails. I can't. Okay, whoops. So this fails. Okay, so graphing these inequalities is actually very quick. What's adding way more time is you grabbing two arbitrary points, one in the shaded, one in the unshaded, and verifying the accuracy of your inequality, true or false or fails, okay? It is a good skill because if ever you're taking a test and you need to know your check, you just substitute a point back in and you verify it, okay? All right, so here we are with just a y and just an x. These are very easy, but students, because, you know, in your normal algebra classes leading up to this class, you don't graph a whole lot of them, or they kind of make appearances here and there. And so just, you know, they're so easy, but we all need a reminder every now and then, okay? All right, okay, so look, it's just y, there's no x. Okay, if the axis is vertical, this line is gonna go opposite that. So this is gonna be a horizontal line, okay? So all you do is find this number on this y-axis. So 2, 1, 2. Okay, so now it's greater than. There is no equal to, so it's gonna be a dashed line. Right? And now you have to decide above it or below it. How do I shade? Well, you want greater. So again, do you want positive 25 or do you want negative 25? Positive 25 is greater than negative 25, so I'm going to shade above. And so there you are. It's graphed. It's so easy, right? There's no rise over run. Okay, how do you verify? Grab 2 points. So grab, to get fancy. Okay, grab 0, 4, grab 0, 0. Okay, so 0, 4, 0, 0. Y is greater than 2. Remember, this is x, this is y, this is x, this is y. Okay, and now substitute. Now, there is no x here to substitute, so I cannot substitute in an x. I can't. There's nowhere to put it. And don't force it, right? So throw in the 4. Is 4 greater than 2? Yes, that is a true statement. Okay, throw in this one. Is 0 greater than 2? Nope, that is false. It fails, right? False, fails. And there you go. That's it. Okay, next, x is greater than or equal to negative 4. Okay, so if your x-axis is horizontal, the line is going to be opposite, which is vertical. So all you do is find this negative 4 on this axis. So negative 1, negative 2, negative 3, negative 4, right? Okay, is it solid or dash? It's, whoops, my hand's in the way, sorry. It's greater than or equal to. Equal to, so that means it is solid. So there's my solid line. All right, you want greater than. So again, look at your x-axis. Do I want, and now we're talking about the x, so I'm not labeling the y, I'm talking about x, x, x. So do you want positive 25 or do you want negative 25? So positive or negative, greater. This one wins, so you're going to shade to the right of this line. Okay, so now then, pick 2 arbitrary points to verify. So I'll pick 0, 0, and I'll pick, negative 5, 0, right? I won't get too fancy. Okay, I have x is greater than or equal to negative 4. Now, I have negative 5, 0. Oh, this one's going to fail. Let's put 0 here and negative 5, 0 here. Let's keep it, right, constant to what we've been doing. Okay, so this one's going to hold true. This one's going to be a false. This one's going to fail. Okay, you only have an x here. You do not have a y variable. There's no y, just like above, you didn't have an x. You don't have a y here, so I cannot substitute these. So I'm only going to substitute the x. So now 0. Is 0 greater than or equal to -4? That's true, yes. And so that's why I shaded correctly, because 0, 0 is in the shaded region. Okay, -5, 0. Throw in -5. Is -5 greater than -4? No, -5, oh my goodness. It's -6. Let's put it right there. Right, -5 is greater than -4. No, that's false, and so it fails. Finally, after what? We're on week 7, week 6. Finally, I made what, like 3 mistakes going through here? Sorry. But I'm watching this with you, so I'm letting you know ahead of time. Okay, here's the assignment. All right, your graphs better be handwritten. For those of you sending me Desmos screenshots and doing it on computers, it's not accepted. Okay, handwritten. Graph neatly, right? Dashed or solid, right? So like I did, right? Here's dashed. Here's dashed. There's solid. Okay, then you're going to shade and verify 2 points. The verification is all the blue markers. Okay, that's the verification. Grab 1 point in the shaded region, 1 point in the unshaded region, right? So that's what I did with all the blue marker. Okay, here are your lines, inequalities that you're gonna graph, shade or solid, dashed or solid, shaded or unshaded region, and verify 2 points, okay? Okay, question 5, I will eventually do for you. So all of these are very much like what I did up in the examples. Number 5 is one that I did not do in the examples, and that's because see how you have that negative right here? So when you take the 4x and you jump the inequality, right? So it's going to be -4x. You now have that -1 that you need to divide out or multiply, whatever makes sense in your, that you prefer, that makes sense to you, okay? And it's just preference. So if you divide by -1, remember when you divide or multiply by negative, you switch the inequality. So instead of it being greater than, it's going to be less than. Okay, so number 5 is, I guess, the toughest one that's on here. Okay, do not graph all of these on the same coordinate system. You won't get any credit for that. So just like here, I put each one on a separate little coordinate, okay? Keep your graph small if you want, right? You don't have to make them massive. And remember, I'm incrementing by ones here. If you want to put them all in one sheet of paper, right, like this, you can go by 2, 4, well, -2, -4, -6, -8. You can do that. It is accurate as long as you are consistent. Okay? All right, we'll watch this together, but it's on 20 minutes. Okay, have a great day, everybody.